Thanks.
Okay, I hope I'm audible. Good afternoon to everyone. I hope you had a very good session in morning and in afternoon. It's my privilege to introduce you our third expert, Engineer Indresh Bhatia sir. He is a senior manager at Xylem Water Solution India Private Limited. He is currently leading the Embedded Harvard and Furman Center of Excellence within India Technology Center and responsible for engineering management of the new product development. He has very vast experience for developing solution in embedded firmware design, electronics hardware design, PCB layouts, and electromechanical product design. He has total 16 years of industrial experience working for developing smart products and solutions. Now I request Engineer Indresh Bhatia sir to kindly share your valuable input on title Industrial IoT. Sir, over to you.
Thanks, Robin. Good afternoon, everyone. It's my pleasure to give a small chat on this topic, which is very vast, and to such a respected audience, which is kind of faculties from all the colleges. Thankful to Bhargav to reach out to me to give me an opportunity to talk in this session. I being kind of an student of BVM Engineering College, and the audience here is kind of some of the audience still is my past faculties who have taught me, and based on those teachings and learnings, I'm here what I am. So great regards to all the professors and the esteemed guests who spared the time to attend this lecture. Feel free to reach out to me any point of time if you want to interrupt me, if you want to kind of reiterate on any of the topic. Feel free. I'm very new to this particular platform, which is Zoom meeting. We are normally used to Zoom, but this one is kind of a new platform. So I'm not sure if we have the chat option here. So you can, if you have the chat option, then you can put that on chat, or you can unmute yourself and also kind of interrupt me at any point of time. I'm perfectly okay with that. And for any questions, for sure, I'll reserve some time so that we have more interaction, and I'll be great if I can solve any of your questions. Okay, I think, should we start, Robin, with the presentation, or we just give
yes.
more people to join in?
Yes, sir, you can start.
Okay. All right, let me just share my screen. Let me know if you're able to see my screen, if one of you can confirm.
Yes, sir, it is visible.
Thank you. Perfect. Okay, so Robin already introduced me. So he very rightly said, give my introduction. So my name is Indresh Bhatia, and right now I'm a senior manager at India Technology Center. I graduated out of BVM Engineering College in 2004, and then I did my master's in electronics from MS University with microprocessors as my core specialization. I completed that in 2006, and after that I joined ABB with their R&D center, and I worked with ABB for about 11 years, and we were responsible for the complete product design for one of their product lines. The entire product design, right from electronics, hardware, firmware, I would say connectivity, communication, mechanical enclosures, etc. They're all under our responsibility. We were a group of about 14 to 15 people there, with different people from different skill sets and different experience levels, working together for product design. And I would be fortunate enough to share with you that the products that we design at that phase, right from 2006 up to 2015, I would say, those are right now in production. And just today, I kind of got one picture of that installation in our Kutch wind farm that is being inaugurated by our PM today. So very glad to see that picture of our hard work being in field. So I joined Xylem in 2016, and I'm leading the Embedded Hardware and Firmware Center of Excellence, as they call it here, for the India Technology Center. With the India Technology Center, we are supporting the entire Xylem business for their research and development activities, product design and solution design activities. We are about 200 people here at Vadodara campus, and we have a campus at Bangalore, where we are about 170, 180 employees, working from different skill sets, working for different business units, and providing different kind of solutions to our global business. Just for a introduction, Xylem is in water industry. So wherever you see water, there should be a product or solution coming out from Xylem globally. We are spread across 30 or 40 different countries across the world. So that's just a brief introduction on top of what Robin had shared. Let's start this session. I'll kind of show you just one picture, and if someone of you can just tell me what can they see in this picture. Anyone? Any thoughts? What do you see in this picture? Okay, let me help you then.
Smart home. Smart home.
Smart homes, perfect. Anything else that comes to your mind? Okay, that was bingo. So smart homes, yes, it's kind of depicting a smart home where you have connected devices. The day-to-day devices are all connected by some means. I can also see a factor of convenience where you can have a coffee machine and then you can command your coffee machine to kind of brew a cup of cappuccino. Okay, you can say that, hey Alexa, can you get a cup of coffee for me? Okay, no physical switch turning on, no cables, no wires, nothing. It's just based on your voice that you get a cup of coffee which is ready. So it's kind of a factor of convenience. I would say it's kind of cloud computing. Why it is cloud computing? Because it understood my voice. There was no physical computation. There was no physical wire. It understood my voice and it prepared a cappuccino for me. So it decoded what I want. It decoded who wants it. So that's how I put it as computing and cloud. I also see a factor of communication over here because I requested somebody to do some action and the receiver received that communication properly and it performed on that action. So my command did traverse through somewhere in the sky and it reached somewhere and somebody did act upon that command. So I will call it as wireless network. There was no cables, as I said. So my voice command did travel through some medium, reached an endpoint, and somebody took an action upon it. So there is a wireless network that was involved in this. And the fourth aspect that I look at it is safety, because this device has to act only upon my command and it has to act upon as my wish. When I say turn on and get me a cup of coffee, only then it has to turn on and give me a cup of coffee. If it does not accept my commands, then it can destroy itself. If it kind of, for example, remains on continuously, the motor can be burnt off and the device can be damaged. Or in other ways, if it does not behave or it does not act as expected, it does not act on my commands, then it is of no use to me. So in a technical parlance, I would put it under cybersecurity. So it has to be safe, it has to be secure, and it has to be responsive to my needs. So this is kind of the 4 pillars of what we call as connected systems, or what we call as Internet of Things. So according to me, and these are the 4 pillars on which this entire concept resides upon. And then you guys can still have different aspects of it, and it's a very, very open technology. It's very, very open. I would say it has a lot of ways to be looked upon, but that's how I look at it. It's my one of favorite pictures for this topic. Quick definitions on what is Internet of Things, how people call them. So these are theoretical definitions. I just will read out a couple of it. Network of connection between objects, where usually the network is wireless and self-configuring. It's an exchange of data over a wireless network between 2 or more things. It's kind of by embedding short-range mobile transceivers into a wide array of additional gadgets and everyday items, enabling them new form of communication between people and things, and between things themselves. It's a network of physical objects, devices, vehicles, buildings, factories, other similar things embedded with electronics, software, sensors, and connectivity that enables these objects to collect and exchange data. So these are some of the definitions. You'll find a number of them. Every user of this technology may have a different definition, but these kind of sum up the concept. This word of kind of Internet of Things was kind of coined by a British entrepreneur called Kevin Ashton in 1999. So that was the period when this concept started. Typically, IoT is expected to offer advanced connectivity of devices, systems, and services that goes beyond machine-to-machine communication and covers a variety of protocols, domains, and applications. The interconnection of these embedded devices, including smart objects, is expected to usher in automation in nearly all the fields, while also enabling advanced applications like smart grid, and expanding the areas as much as smart cities. So IoT, as we normally call it, it's Internet of Things, and it's a concept where you have things being connected with each other. Where is Internet of Things? I would say everywhere. I would say take any device, take anything, be it your mobile, be it your computer, laptop, that can connect with a network or that can connect with an internet. It could be anyone, anybody, any person. He can connect to the internet. You have a lot of smartwatches, your healthcare devices, they're all connected. Your day-to-day calorie counting, your day-to-day kind of recording the number of steps that you did. So it's kind of on a personal level, I would say. Any service, any business that gets connected with the internet is a part of Internet of Things. It can be any part, any network, any kind of network topology that you can visualize can be a part of Internet of Things. It is available everywhere, I would say, any place, anywhere. What it needs is just an internet, and it's anytime, any context. So it's always available, it's responsive. It's like 24/7 service availability. Now, since the subject is so broad, we can clearly divide it into 2 major categories. One can be a consumer category of industries. So we can call as consumer Internet of Things. Another category is like industrial Internet of Things. So what comes under consumer is like your wearables, your entertainment, appliances, home automation, the picture that we just saw on the first slide. That kind of falls in the consumer Internet of Things. So today you have numerous examples where you are connecting the things with your mobile app, you're controlling the things with your mobile app. I mean, it improves your day-to-day lifestyle to a lot of extent. You have your cars getting connected, you have your ACs are connected, your televisions are connected. So they all fall under consumer categorization. If you look about industrial Internet of Things, then I would say the industries like transportation, energy, automation, all your factories, healthcare. You look at any industry, any factory, you can connect now with the Internet of Things concept. So that's how we call that concept as industrial Internet of Things, or IIoT, which is practically the topic for today's discussion. So again, a small definition about what is Internet of Things. So industrial Internet of Things. So the IIoT, as we call in the short form, is also industrial internet. It brings together brilliant machines, advanced analytics, and people at work. So today our focus will be more on industrial Internet of Things, and the background, or the foundation of industrial Internet of Things lies upon analytics. It lies upon machines, it lies upon analytics, and it lies upon people. Why people? When we are talking about machines, when we are talking about analytics, we still need people, and we still need their intelligence to work upon that data, what they get from this concept. So we need people who know their business. We still need people who know the business intelligence, I would say, and then how they apply that business intelligence with this data which is coming from the machine. So that's how the analytics works upon. So the people still are as much critical as you have the technology, I would say, in this frame. It's a network of multitude of industrial devices which are connected by communications technologies that result in systems that can monitor, collect, exchange, analyze, and deliver valuable insights like never before. So here we are talking about devices which are connected, devices which can communicate, devices which can monitor any given parameter, the devices which can exchange those parameters within each other. You have the devices that can analyze a few aspects of your system, of your industry, and based on all these devices, all this data that these devices produce, you apply some intelligence on top of it, you apply some analytics on top of it, and then you can get a very good insight about your process, a very good insight about how your system is working, how your industry is working, right? So for example, it can enable predictive maintenance to detect corrosion inside a refinery pipe. So you can have a multitude of sensors within the pipes which kind of give you a lot of data with respect to the flow, with respect to the pressure, with respect to maybe the conductivity of the material. And then based on those data, you apply some algorithms on top of it, and then you can say whether your pipes are being corroded or not. It can provide you real-time production data to uncover additional capacity. It can, you can deploy various sensors on your machines, which can tell you how much your machine is actually loaded, and then you really get to know what is your real capacity utilization of the machines in your plant. So do you have a capacity to extend your production, or are you overutilizing your machines and thereby you are increasing the wear and tear of your machines? So you can get all those insights if you have the data. It can accelerate new product developments by feeding the operations and service data back into the product design cycle. So you work years together, you work out on a solution, you have a great product, you launch it in the field, but can you have feedback how that product is being used, how that product is being deployed in the field, how the users are actually using it? How do you get that data? You must have, when you have designed the product, you kind of must have done a lot of research on your application where it is going to be used, but that's still at a research level. Having this concept of industrial Internet of Things, you actually get the feedback from your actual product. So what are the conditions it is facing, whether it is performing at the required optimal levels, or is it getting the environments which it was not designed for? So So all those feedbacks you receive from your product, from the systems, and you then feed it back to the operations, you feed it back to your development teams, and then they automatically get the feedback how the system is working, and they can improve upon the product, and they can improve upon the solutions. And that's how you kind of give it back to the customers. And then you're solving the purpose of your customers by these insights, actually. So it connects machines, it connects devices in the industries. Industries can be any, oil and gas, power generation, healthcare, and it finally helps the users to get a better experience and insight into their assets. So the user who is actually buying out your systems, the user who is investing in your systems, in products, is he getting the best experience what he expected? Okay, so you never know. It's your perception about a product that, okay, I have designed a great solution, and this solution will meet your expectation, but you never get a real feedback from the customer. With this kind of concepts built in your systems, you get that feedback, a real-time feedback from the customers, and then you can improve upon it, and customers can have better value of their assets. So the industrial Internet of Things offers its distinctive advantage by connecting the data from different devices, generating the relationships between them and their operating environment. So it helps us to generate that relationship of the system, of the, I would say, the sensors, of the solutions that you have brought in, and where they are being operated. You perform data analytics, you get a lot of data, you perform analytics on top of it, and you get the results, which improves efficiencies, yields, and it reduces unplanned maintenances for the end user. That's why he kind of invested in the systems that we built. The concept of industrial Internet of Things revolves around using smart sensors and actuators that can enhance manufacturing processes. So one of the pillars of this concept is smart sensors and actuators, which are kind of the eyes and the, I would say, hands of the system. This is a concept that takes advantage of data generated by our dumb machines over years and make them smart. So we have to act upon data. So the machines till yesterday, I would say, were dumb. They didn't have those sensors. They didn't have those eyes and legs, I would say, to give you the data and to act upon the feedback. So it has to be a closed loop system. So you generate the data, you act on that data, and then you give that as a feedback to your machines, and then they improve themselves. So that's how I use the phrase of dumb machines and smart machines. The dumb machines without sensors, smart machines with sensors. How it exactly works? You have the edge devices on the machines that converts them to intelligent assets, which can sense, communicate, and store the information about themselves. So you take any machine, you visualize any machine, and then you put upon the sensors on those machines, and you kind of monitor various parameters. It could be pressure, flow, it could be the temperature, and then you have the edge devices. What are the edge devices? These are the devices on which you connect your sensors, and then you have, it's more of electronics, I would say. So you have the sensors which are connected to the electronic condition monitoring circuits. You have the controllers or microprocessors. You have the software written on top of it. You have some powering mechanism for these devices. Now, what is the difference between an edge device and a normal sensor interface module? I would say it's that the yesterday sensor interface modules, they were simply getting the sensor data and communicating the raw data. Okay, so they were not adding any value on top of it. You still had a lot of filtering, etc., but that was still raw, I would say. That didn't have any intelligence on data part of it. It kind of eliminated, if you think from pure electronics perspective, it eliminated noise and the real signal. But the real signal, yes, it is a real signal, but that's only a signal which you communicate in terms of digital languages. Edge data, what it does is it adds some intelligence on top of that data also. So let's say if I'm having a temperature sensing module, every 1 minute or every 5 minutes I'm sensing the temperature, and I am sending that temperature that, let's say it's 22 degrees centigrade, and every 1 minute I am generating the same data, that is 22 degrees centigrade. When we are building this concept of Internet of Things, when we are building this concepts of large scale devices being connected on your systems, when you are building this concept, you will have a lot of data actually. Now, does it make sense that every 1 minute you send out a chunk of packet which says it's 22 degrees centigrade? It actually doesn't make sense. My purpose is to see, my purpose is to do some analytics on top of it. Now, if that data is flat for, let's say, 24 hours or 48 hours together, it doesn't help me in my analytics. I want to see variations. So edge devices are the devices where it gets the same temperature data of 22 degrees centigrade, but it will send to the cloud only when, only on a predefined algorithm. Only when it sees some change, it sees there is some movement on that data. It sees that the data is fluctuating on certain conditions at every, if it sees a logic in that data, let's say at every day about 3 o'clock, my temperature is rising. So it will generate that correlation, and that correlation will be sent to the cloud, and not 1 minute, one packet kind of thing. So that's the difference where the edge devices comes in picture. Data communication infrastructure, that are our communication gateways. You can have a lot of communication protocols which can connect to these edge devices, and then you form a device network. It could be wired, it could be wireless. When I say wired, it could be wired to a gateway which acts as a master control, and then you have further wireless connectivity down up the stream. It could be straightforward wireless, it could be on Bluetooth, Wi-Fi, Zigbee. We'll see all those communication protocols in the coming slide, but it could be any communication protocol, but there is a communication infrastructure in between after your edge devices. And on top of it is the business logic. So where you are actually getting the data from this device network, and then you are performing that intelligence that, okay, I'm getting from my edge device that every day at 3 o'clock my temperature is increasing. So there must be something going on in the building, why that is happening. And then you can accept that data, you can decode that data, you can work on that data, and you can further apply a logic, apply an algorithm, and kind of give feedback to your machines why it is happening in the building, for example. Okay, please let me know if I'm going too fast. I can slow down a bit. Okay, so this slide again gives the same thought process, how these infrastructures are layered. At the bottom, you have the sensors, which are, as I explained, generating all the data, which is fed to edge device. These edge devices are your input-output modules. It can be open loop, it can be closed loop, it depends upon your application. Certain applications can have closed loop, and then you have the actuators, which kind of take those commands from your devices, and then finally they act upon the parameter. If it is open loop, you can just send the data one way upwards to your communication gateways, where your protocols come in picture. From the communication gateways, you connect to your clouds or server, and on top of the cloud on the server, you have the business logic. Now this infrastructure, it looks very big. If you visualize, it's a huge infrastructure, but again, it depends upon application, it depends upon our need. We may have application and needs where we just want to get what's happening. It's kind of one way, so you just have sensors, you edge devices, and a very simple, I'll say a mobile app or a web app where you see what's happening. You want to have multiple systems connected, so you need gateways or protocol converters. You want to take it to cloud. I mean, you can still have applications, you have multiple systems connected, multiple edge devices connected through your communication gateway, but it's still local. You still do not need cloud-based performance. I mean, you are still okay if you just have the gateway being connected via Ethernet cable to control room, for example. Okay, So it's still okay. It's still a part of an IoT. You can still call it as an IoT. It doesn't mean that it is not an IoT. You may have a bigger application where you want to get that data from any place in the world. So then you connect it to cloud or a server, and then you have the concept of internet, by which you get that data sitting any part of the world. You still just want to have one-way feedback. So sitting any part of the world, you just want to see how your systems are behaving. So it's absolutely fine. It's still a part of IoT. And then if you want to take one step forward, then you need to have your business logic, your data processing logic, and then analytics. So then is where the cream comes in, which gives you an edge over your competitors. So if you have that part of it, the business logic part of it, then you are completing the IoT infrastructure, and then you kind of can get an edge in the market against your competition. So this is where you spend a lot of your time, you spend a lot of your resources to analyze that data correctly and take the right actions. Now, when you analyze that data, you take the right actions, you also need to send it back the same chain. So this chain can be unidirectional from sensors up to the logic, or it can be bidirectional. Now, each of these chain actually is a subject in its own, which needs a lot of study, which needs a lot of components in hardware, it needs a lot of components in software, in the design, and that ensuring that this chain works seamlessly. So it looks pretty simple over here on our screen, but each of this block is a subject in itself, I can say. Expanding that same block to slightly bigger sized, I would say, to give some more aspects. As I said, each of that block is a subject in its own. Now this slide shows a little more detail than the earlier one. So you have sensors and actuators on one side of the block, and then the part that we call as edge devices can also be called as things, where you have your devices, you have the sensor interfacing modules, you have your microcontrollers, you have your connectivity, that is a physical chip that actually communicates, the Bluetooth, wireless, LoRa, or whatever. Then you have protocols on top of it, and then you have an operating system on top of it. So this is kind of a subdivision of the devices section. These devices then connect with your network. So that network could be a gateway, which again has modules inside. What is the input protocol you have? Does it support Modbus, BACnet? Does it support RS-485, RS-232? Any of my communication protocol can be an input to the gateway, and output of this gateway will be, where do I want to connect? Do I want it to connect to Ethernet, straightforward LAN, or do I provide a Wi-Fi connectivity, or do I provide a cellular connectivity? So it can kind of do a lot of things actually. You can also convert from one protocol to other protocol. So for example, my system is supporting BACnet protocol, but I want to still get that data on a SCADA. Okay, so then my communication gateway will convert that BACnet into a Modbus that can go up to SCADA. Okay, and from that SCADA, I actually have the APIs which send to cloud. So all those conversion of the protocols, all those conversion of the data happens on this network layer. Once you have the data, which is the output of the gateway, that gets connected to your cloud. Now, cloud again has two parts. So one part is the core cloud, or the server part of it, where you have your data centers, where you have the hard disk, or it's a physical part of it, the memory, the computational power of your servers, the operating system of the server, the security part of the server, and your business logic, which is kind of predictive maintenance concepts, the analytics concepts. So that forms my cloud. So again, this is a very, very representative fact of these layers. If you start working at it, you'll find companies who are specialized in the edge devices, and they offer a lot of functionality on the edge devices, a lot of features on those edge devices. If you look at the network providers, then again there are a lot of companies who are specialized just in the network management activities. They are companies who are specialized on the gateways. You just name a protocol and you will find a gateway which can convert that protocol in so many other protocols. Then if you look at the server part of it, there are a lot of companies who are specialized in providing these services for maintaining your servers, both hardware and software part of it. And then there are a lot of companies who help you to develop these intelligent analytics part of it. You can name a few like Amazon, you can name a few like PNR, you can name a few like ABB, and there are numerous companies who are working nowadays on these concepts. So I'll pause here a bit and check if there are any questions till now.
Actually, what is the basic difference between IoT and industrial IoT? Because whatever we are discussing now, it's also, there in IoT. So where we can, separate out both industrial IoT and IoT.
Exactly. So it's a great question. Let me again go back to this slide. So if you look at the right-hand section of it, that's where you can call it as an IoT, where you use technology in your day-to-day life. Okay, that's a kind of a very generic answer to your question. If you use the technology in day-to-day life, that's an IoT. Okay, and if you call it an industrial IoT, it means that when you're actually working with the sensors, when you're actually working with the gateway devices, and when you're actually inferring that data out of the gateway devices and putting it back to your machines and make them more efficient, that's where I would call it as industrial IoT. So you can rename it also as like Industry 4.0 concept or smart factories concept. So these are the different names of these concept. It's actually concept where you are making your assets, which is your machines, more smarter.
I mean, protocol-wise, there is no difference. Protocol-wise, both is same. Whether you send the data,
it is quite the same. Yeah. So the protocol and the infrastructure is more or less same. The only thing is that if you talk about a consumer IoT where you have connected devices which you use in day-to-day life, the infrastructure requirement is a bit lesser because it's for sure cost is one of the very big factor on it, and then the intelligence level that you need is a bit lower on it. It has to be a very, very user friendly. So the users of your consumer IoT part are kind of considered not so tech savvy. They should be easily using your systems. Okay, so you can't make them very complex. Whereas when we are talking about industrial IoTs, we are talking about on a totally different scale, where I'm looking at tens of my pumps, for example, connected, which are supplying water to an entire shopping mall or an entire 20-story building. If one of that pump fails, the water supply to the building might stop. If I take an example of energy sector, you have big substations, right, which provide electricity to your homes. Now, if one of the transformer in that substation fails, it will be a complete blackout to so many of population, right? So many of people will lose electricity. We can't, the company, the organization who is providing electricity cannot afford to do that. The organization that is providing water supply to the particular community, to a building or shopping mall or maybe any application cannot afford to do that. At the same time, they also need to ensure that those assets that they have invested, for example, in a state-of-art transformer, which has a very less failure rate and it is very efficient. It's a hell lot of a cost. they can't also afford that to see that transformer is being underutilized. They can't also afford to see that that transformer is overutilized. They can't afford to replace a transformer when it is actually burnt out, right? So they need the data before that. Now, when I say they need the data before that, it means they have to have those systems in place which can monitor my condition of the transformer, which is called as condition monitoring or predictive maintenance. So till now, the organizations were working with the concept of, I would say, maintenance, periodic maintenance, annual maintenance. These were the concepts which companies are kind of working with. So every 1 year they'll come, they'll check the oil, they'll replace something, and that's kind of a periodic maintenance, annual maintenance. But sometimes it might not be required. So maintenance is required only when there is something to be changed. So if my asset itself can tell me that, hey, now it's the time that the oil should be changed inside the transformer, that saves a lot of energy and a lot of money for the organization. Now, how that transformer can tell me that now is it time for changing the oil? Those concepts need this high infrastructure. Those concepts need high-end sensors. Those concepts need those edge devices which can filter out my unrequired data. And those concepts need good amount of cloud and a good amount of analytics, because it's not very easy to detect when should the transformer oil be changed, right? So it's not very easy. You need a lot of analytics on top of it, on measuring what is the right parameter of that transformer. So those kind of things I would put under industrial IoT. So that is one example of asset health monitoring, which is a very big concept which is being done by industries. Second concept of industrial Internet of Things will be smart factories. So you can assume that you're running a factory, but you never know what is my capacity utilization of factory. It's kind of just by judgment of various parameters, which is traditional way of monitoring the capacity utilization of your assets or the factory. But then if you can measure that, the optimum usage of your machines, if you get that data, how much hours of my machine is being used, how much hours my machine, if I'm talking about an industry, right, not a standalone factory. So if I have factories in 10 different cities, I can collect that data from all my factories on a central server and see that, okay, there are 3 weeks where factory 1 is overloaded, but there are 2 weeks where in the same 3 weeks, the factory 2 is kind of underutilized. So can I shift some of my production to factory 2? So if I get that data, if I put that intelligence, and then that's where I call it industrial Internet of Things. So these are two broad examples which can give you an insight about industrial Internet of Things.
Can we do much more classification, like if it is useful in agricultural, then AIoT, if it is used in healthcare, HIOT, and so on? Because
yes,
it's a kind of Internet of Things. Yeah, like that. Okay. And
yeah,
like in military, military IoT and so on. Right.
Yeah. People use those words.
And in the industrial, whenever we use IoT, we call it as Industry 4.0, right? It's the version 4.0.
Yes, Industry 4.0 is the latest name that we are using for concepts.
Industrial IoT. Okay, thank you. Thank you very much.
Yeah. Thanks for that question. It was a great question and timely. Okay, so let's move forward then. So data in action, this entire concept of Internet of Things or industrial Internet of Things is resting upon data. So sensors are the most critical part of this concept, which generate the data. We might think that it's a very small thing. It generates very small bytes, which are simple data representing the sensed information, kind of temperature, humidity, current, voltage, moisture level, as you said in agriculture, status, position, limit switches, where it is latched up, etc. But it looks very small when you look at a specific asset or a specific function. That's how we call as little data, because it is just coming from one particular device. once you form a network of these multiple devices, each of these devices will send this little data up to the network, through the network up to the cloud. And then where in the cloud you're having all this analytics, all this business intelligence, and you're consolidating all these data coming from different devices. There, if you look from the cloud perspective, then it is a huge chunk of data. It's kind of, you can't even imagine the tons of bytes that you have there. And that's where it gets changed, the name gets changed, and they call it as big data. So big data is the one which is at the topmost part, I would say, of the IoT pillar. And then if you have the data, you can do those analytics. Without data, you can't really do anything. So this is the big data, which is a collection of individual nodes, individual devices, which gives you the possibility to do all those analytics that we're talking about. So this, so these analytics from sensors that allows us to connect the events to results or actions. So for example, we know that during summers in India, it will get darker later, whereas in winters it will get darker earlier. So we can have smart street lights. Now that smart street lights can be configured that they use ambient light sensors. So it's not, it's one way of doing it is you hard code it that, okay, during these 4 months, you have to start at, let's say 6 in the evening and stop at, I would say 8 in the morning, or in these 4 months, you have to start at 8 in the evening and stop at 4 in the morning or 5 in the morning. So that is very, very crude way of doing it. Okay, it is still smarter way because you are saving the electricity, you are saving efforts in terms of somebody going there and turning on and off. But a smarter way of doing it, a much smarter way of doing it is you get the data at a central server and you analyze that data, and then you can say that in these 4 months, it's like 6:30 in the evening, I should start my street lights. Or it's like 7:30 in the evening during these 4 months, I should start my street light. So you can adapt to the change through your data. So you can have those sensors in the street light which give you that data when it is darker. Okay, so it can give you some kind of a image, and then you have those processing of the image, and based on that concepts you can program your system so that it gets those adaptability, and you are saving that electricity, you are saving efforts, and you're giving a better experience to the user. So user can always see that, yeah, it's the street lights are kind of turning on and off at the right time when there is a right amount of ambient light. So user always gets, I would say, priority. So user experience gets the priority when we are looking at these concepts. Okay, that's another example. Okay, having said that, we'll talk a lot about sensors. Let's just see a lot of communication protocols are available, which we can choose from on top of these sensors. So it could be satellite communication, Wi-Fi, Bluetooth, BLE, Zigbee, cellular, 4G. So there are a lot of communication protocols, as I said earlier, which are available as of now. Technology has matured for all these protocols. You have ready solutions which you can adapt to. It's just up to you as a system designer that you need to carefully choose which communication protocol you should select based on your application, based on your application, based on your needs, looking at the cost, looking at availability of the infrastructure which supports these communication protocols. You need to see the total cost of ownership. You need to see the scale of scope of scalability, how much scalable these solutions are. Let's say you start with a small pilot, but you feel that now you need to expand that. So that protocol should be scalable. Okay, so the next layer after our, I would say, device protocols was cloud computing. So if you look at cloud or a server, what do we need for and what does it provide for. So it can provide me my configuration management, it can provide me logging, it can provide me load balancing, capacity planning, priority management, security assessment, my resource allocation. It can help me to be adaptive, to respond to change. It can give me a fully automatic system, can give me a universal access. Anybody can access from any part of the globe. It can give me an on-demand service. Whenever I need it, the system gives me a service. It gives me a next generation ready solution. It gives me an interoperable system. So these are the features that that are provided by cloud. So we must be thinking that why cloud? Why can't we do that on edge device? But yes, edge device has its limitation. It cannot give me these kind of features. If I'm looking at these features, I need to go to the level of cloud. As I said in my earlier slide, we have different layers of the infrastructure. So if I want features like this, if I want my feature to be adaptive, if I want my system to be fully automatic and responsive, if I want my resources of my system to be shared equally, I will still need cloud. So there's no other solution. If I want my system to be secure, I still need cloud. And when on security is again a tricky term actually. So on one side, I'll say that if I need security, I'll need cloud. On the other side, I'll say if I have cloud, I'll need security. That's on both sides of the world. So if I look at, just like we looked on the device part of it and the various protocols that we have available, if I look at the cloud part of it and the different layers within cloud, I would say the mobile app or the website that we kind of designed, that is our front end, which can be terminal desktop, which is used by the end user actually, which provides me all the information. But that's just the front end of it. If you look at the back end of it, we have internet, we have software as service. Software as service, this is a component which gives which works for web browsers, which works on thin clients, which works on APIs, which is being used by our desktops and mobile apps. So they are communicating on APIs. APIs are the communication protocols of the software language, you can say. On a layer down, the SaaS is PaaS, which is platform as a service, where you actually are working on database management, web servers. So when I say that you need to have the IoT concept links bunch of edge devices together, bunch of sensors together, you need to have kind of a database which has a specific identity to each of your sensor. You still need to know this data is coming from which sensor, from which location, from which factory, from which device. So who is the user, who is the owner of this particular device or this particular system. So if you have to do analytics, you need data, you need to manage that data, all that given, but it also has to be structured. So you need those database management concepts. So that's a second layer in this, I would say. A layer below that will be your infrastructure layer. So that's kind of an IaaS, as we call. So where you are actually managing the hardware part of it. So it's hardware management, hardware monitoring, that my servers are all working correctly. What's my temperature rise of the servers? What's my loading of my servers? So if one of my server goes down, can I handle the same load with the balance of the servers? So how do I share my load? How do I cluster my servers? So that is again what we need to look at. And the last layer in this chain would be the actual servers, which is my CPU, hard disk, RAM, firewalls, networks, etc. So this, again, each of these layer is a subject in its own. It's very easy to put it on a slide, but yeah, each of this layer has people experienced working into each of these layers and providing that seamless connectivity between all these layers. Because what you are implementing is what I call as analytics or business intelligence, is kind of on this layer, on your software as service. So this is where you implement basically your business intelligence. To a certain extent, it goes on database management or computing platform, but that's it. You still need in physical infrastructure, and you still need to monitor that physical infrastructure in order to enable you to provide these two services. which is the heart of IIoT. So there is an aspect of management of these layers. At the same time, as I said earlier, there's also an aspect of security of these layers. So cloud gives me security, but at the same time, I need to secure cloud. Okay, before going to security, that's kind of a second topic. Just pausing here to check if there are any questions till now. No questions? Okay, wait. So now this is probably the last part of my session. So where we just talk about the security part of it. So we saw devices, we saw networks, we saw cloud, and with cloud comes its vulnerabilities also. So when we are building an industrial Internet of Things kind of a system or a Factory 4.0 kind of a system, I should ensure that the data that I am communicating end to end is integral, it is available, and it is confidential, because it is carrying sensitive information about my system, it is carrying sensitive information about my business. So these are the three major pillars that my data should fulfill at. How that can be done is we can have firewalls, we can have antiviruses, we can have OS upgrades. At the same time, the data, as I said earlier, should be available 24/7. The system should be responsive, it should be adaptable. So I should have my proper backup managements. I should have my incidents management in place. So what if some of the servers go down? So there should be a backup server which still provides my 24/7 connectivity. I should be fully prepared for denial of service kind of attacks or any VAPT kind of attacks. My system should be strong enough to filter out those attacks. I should have proper concepts of authorization and authentication. The data should be available only to the people who are authorized to receive that data. The data should be available to the people who gets authenticated. So it's as simple as like we get the entry to our offices only when we scan our cards, or our attendance gets recognized only when we kind of put our fingers or kind of look into our machines. So it means that we are authenticated and we are authorized to move further. It's the same concept with the data. So when we are communicating from our devices to the network to the cloud, so that data should be always authorized. It should not, people can use a lot of cyber attacks where they can just use kind of deny the services. So they can flood your systems so that the data doesn't communicate from one end to the other, and then the user doesn't get what he needs for. The data should also be encrypted, so you cannot, so that someone cannot sniff that data. So when we are communicating sensitive information, it could be kind of information about users, it could be the information about their credentials, it could be the users' assets, critical data, critical information. Nobody should be able to encrypt that. It's, I would say, if you just have monitoring part of it, as we were looking in the other slide, if it's just one-way communication, you're monitoring it, these aspects can have a bit lower priority in terms of how we are managing that. But if you have a controls, when somebody can control your system from remote, then these are the parameters which you should look at first before designing your system. Because it should not happen that somebody gets your data, decrypts it, and kind of does a wrong control. So it stops or starts the services when they are not required. So remote controls means somebody can operate your systems from remote. So if you are having remote controls in your system built in, this aspect of cloud vulnerabilities become even more critical. There are a lot of ways to implement them, and there are a lot of ways to even perform the checks on these topics. So there are people who are called as ethical hackers. So you can hire them and then they can do the checks how robust your system is against these attacks. In organizations, you also have teams who are specialized for product security and cyber security, and there are continuous evaluations of your systems being done, because a small miss can lead the entire organization down to, it can be ransom to somebody, the entire organization. So it's given topmost importance in the industries with these concepts. Okay, so I think we already covered this part, but let's again go over it. It's kind of a use case for IIoT, which is kind of asset condition monitoring. So it's one of the concept.
Excuse me, sir.
What is asset condition? Yeah, sorry, go ahead.
Yeah, sir. There was a question from one of our participants related to the security. Yeah, Sachin, sir, can you directly unmute and ask your question, please?
Yes, sir. Can we provide a metadata trading using IoT on the 3-layer PaaS, SaaS, and IaaS?
Sorry, please, can you come again?
I'm talking about the metadata tracking on the layers of cloud, PaaS, SaaS, and IaaS using the IoT for a security. Can we provide any metadata tracking technique or algorithm or anything?
Okay, so there are a lot of algorithms that are being deployed on all the layers, as we saw here. Okay, so I may not be able to comment it out because I am within one of the development team. So, but yes, what I can tell you is that we have a lot of protocols which we implement on each of these layers, which kind of protects the data. It protects how the data is communicated. We have authorization and authentication. So, for example, Auth 2.0 is a protocol that we use for our authorization purposes. So, which kind of at every level it checks whether the user that has requested that service is authorized or not.
Okay, so it will provide any data provenance?
It will provide any?
Data provenance, security. Data provenance.
Yes. The data security is happening at each of these layers, as I said. So it does provide, each of these layers have written for this for the data security. They have special algorithms deployed on each of these layers. I'm not very sure about IaaS layer, whether you have any data security kind of application deployed over here. But on the side of it, yes, there are firewalls which you configure for your access. So you kind of whitelist only the devices which you want the access to the servers. So that's here on the infrastructure layer. On the PaaS layer, again, you have database management, which has its own protocols to secure access. And on the SaaS, APIs have encryption. You exchange tokens. There are tokens which gets exchanged during your authorization, and tokens get I would say validated, and only then the API results are created, and that too encrypted. So you have those encryption decryption algorithms between your devices and your servers, the cloud part of it. When you are developing your mobiles or the terminal applications, you still have your I would say SSL certificates deployed, so that they grant access only to specific users, and each request is validated.
Okay, sir. Thank you.
Yeah. Any other questions from any participants? Okay, sir. You may continue. Thank you, sir.
So let's take this use case of industrial IoT, which is kind of asset condition monitoring. Asset condition monitoring means, let's take an example as we took of transformer, right? So it helps to capture and monitor the status of your machine. So whether my transformer is working or not, whether what are my input voltages, what are my output voltages, currents, etc. And based on that, I would say that parameters, I can say whether my system is stressed out or is it working under the normal operating conditions. If I detect that my system is getting stressed out, my voltages are always, or let's say the voltages are always above a given threshold, then I can for sure say that my operating life will be reduced and I can do something out of it. And if I say that the load that this transformer is kind of providing is less than what is expected for, then it is underutilized asset. So I don't need such a high transformer for this kind of an application. Although initially it was designed for this application, but the actual usage is not that much. So I can use that information and see what is my condition of my asset. With this, I can also check what are my vibration levels, for example, what are my flux levels, for example, and then if those vibrations are way above the threshold, then it for sure it will kind of fail. If we take an example of a rotary machine, kind of a motor, and if I can check the vibration of that motor, then there will be a vibration because it is a rotating machine, right? So there will be for sure some level of vibration which should be accepted. But if I can see that that vibration is increasing over a period of time, then I can say that some of the bearings have changed their performance. So some of the bearings have started to deteriorate because my vibration levels have increased. And if I can monitor that pattern of rate of change of increase in the vibration, then I can go and replace my bearings way earlier than it actually fails. Okay. So I can manage the stresses. I can know that my equipment is now working at a higher stress level. So before it fails, I can go and do that maintenance. So that's what is the meaning of asset condition monitoring. Okay, I think quite similar what we just covered. So that I took an example of voltage, current, vibration, but that could be anything. It could be pressure, it could be temperature, it could be position. You take any operating parameter and then you can have a condition monitoring device for that parameter. And if you have those devices and connect those devices and make a network out of it, then you are kind of coming towards an industrial IoT concept. Just a bottom line that was also asked by one of the participants. Unlike traditional software applications, if you look at IIoT, it is rooted in the physical space. So where we are integrating the data from digital devices. It enables enhanced monitoring, data gathering and integration, and role-based information and situational awareness for the operators. So operators get aware about their situations, what are going on with their assets. The operators get that information and the operators can work upon that information. That is the bottom line for IIoT. I think this takes me to the end of the presentation. I think we can have some more questions coming in. I'll just stop sharing my screen and let's have some interaction. Anybody working in this field already? Does it resonate with what you're doing in your industries, or kind of does it resonate with what you're kind of coaching in your classes?
Yeah, it makes sense actually, Mr. Bhatia. It was a good refreshing and a good discussion and really a good session.
Okay, thanks.
So can you show us this some of your live sites if you have?
Yeah, we have a lot of live sites, but unfortunately, I'm not allowed to present that over here. That was something that is restricted. But you can go to Google and search for condition monitoring devices, and you'll get a lot of them. One of them is called as Optimize. Another one is called as an AQ Wi-Fi. It's all condition monitoring based devices, remote interfaces. And then if you go to the website of ABB, you will find something called as ABB Ability. So you'll find a lot of live examples which are publicly available. Because we are doing a lot of work on these subjects right now, which is under work. That's why I will not be able to pull it out and show it here.
So you are working under the channel partnership with the ABB in some of the cases?
No, we are not working with ABB. I personally was working at ABB before joining Xylem.
Just one thing I would like to add what Dr. Viklani asked, that the differentiation between the industrial IoT and commercial IoT. Nowadays, the commercial IoT is also going to be replicated in such a way that it is at the end, the startup is, which is a startup which is just for a health monitoring started, it is getting the industrialized and getting converted into industrial IoT also. So the barrier between the IoT and industrial IoT is now getting diminished actually.
There is, I would say, there is a very thin line between two. So it just depends upon application. Now, if your application is standalone, it's just one system and one user, you can call it as Internet of Things, because there is a thing and there is internet and you are using it. But if there is a collection or a bunch of systems that you are monitoring at a single view, then that falls under industrial IoT. Because and then when we call it as industrial IoT, we are talking about assets like which are used in any of the industry. Okay. So there is a difference between a consumer asset and an industrial asset. So if you're putting something and you're monitoring an asset which is under any of the industry, it could be energy sector, it could be oil and gas sector, it could be water sector, it could be petrochemical sector. So if there is any of asset and you are monitoring the performance of that asset, it is a part of industrial IoT. So you have refineries where you have going from one stage to other. There is a lot of process happening on top of those fluids. And then if you have to monitor each of the parameter of that fluid in that refinery, then it becomes a very big network. And in order to manage that big network, you have these concepts of industrial IoT. Whereas if you are talking just about an air conditioner in your home, it's equally important, but that falls under a consumer IoT.
Yeah, hello. Any more questions from participants? Queries? Okay. So let's end up our session today. I thank Engineer Indresh Bhatia sir for sharing his expertise and valuable time on today's topic of industrial IoT. Sir, it was really very informative and great session, and indeed it would be very useful to all participants in gaining more insights in the industrial IoT. Thank you very much, sir, for your session.
My pleasure. My pleasure.
Hope today's session gained you
pleasure.
insights in line with the theme of our FDP. So shall we call it a day for this for today's class? And tomorrow
Yes,
again
yes.
we'll start sharp at 10:30 a.m. With continuing sequence of the sessions, and hope you will enjoy the learning journey to the IoT. Thank you all. Thank you to the expert and the participants.
Thank you everyone. Thanks to all the participants for sharing the time. Thanks, Dr. Eden. Bye.
Thank you very much, sir. Most welcome, sir.
Bye.
So we are ending up session. Yeah, participants who have not filled up the attendance sheet, just use the attendance sheet to log in your attendance for the today's session, this session.